Hello everyone, this is Dr. Indradeep Kumar, Assistant Professor IARE, Hyderabad. So in this video we will see a problem on direct stress distribution in the thin wall rigid section. Okay, so our lecture topic will be problem on direct stress distribution in the thin wall rigid section. So in this case, jet type section we will see. Okay, so let's see here. The question is determine the direct stress distribution in the thin wall jet section shown in figure here that is given produced by a positive bending moment mx. So this time positive bending moment that is given as what? That mx. So now just see here the dimension is from 1 to 2 that is h by 2. From 2 to 3 it is just h. Now 3 to 4 is h by 2. Okay. So now and this is the shear center. Okay. So for this section we have to find. Okay. So now come to the solution. The section is anti-symmetrical with its centroid at the midpoint of the vertical wave, right? So it's anti-symmetrical, it's not symmetrical from the midpoint. Okay, the direct stress distribution can be given by either of the equation where my is 0. When my is 0, that time that sigma z is what? My ixx minus mz izy by izz, okay, into iyy minus I square xy into x plus mx Iyy minus my ixy by ixx into Iyy minus I square xy into y. That already we had seen. Right. Now, so sigma z will be equals to what? Mx into Iyy into y minus Ixy into x by Ixx into Iyy minus I square y plus my into Izz x minus izy y by izz into iyy, okay, minus ix square y, right? So sorry, this is x. Okay, so now this is our what? Sigma x sigma z value, right? Now this already we had seen, so directly we can use here. So now what is there? What is the condition? Put my equals to 0. So after putting my equals to 0, what we will get? This term will get 0, or you can say this term will get 0. So here this is there. After expanding, what happened? Just got separated. That is the here. This is the general equation. Just after multiplying, and we separated the x term one side and y term one side. So here, right? So that's why mx taken common from this term and my taken common from here, so that we can put my as 0, or simply you can put here also. So this my, this term will get 0 and this term will get 0. So now just see what we will get. Mx iyy minus mx ixx. So that's why x common, right? So mx common. So after putting, or just if you will put in this equation, then this will be 0. Then sigma z is what? Mx into iyy into y minus ixy into x by ixx into iyy minus I square xy. So now this is the sigma z value. Okay. The section properties are calculated as follows. So now section property means what? Moment of inertia about Ixx, that along the axis. So Ixx, Iyy and Ixy we have to find. Okay. So let's find first Ixx. So what is the formula? That BdQ by 12 symmetry. So 2 into B is how much? Right? B is T and dQ by 12. So right. So after taking this, what you will get? 2 into ht by 2 into h by 2 whole square plus t hq by 12. So after simplifying, what you will get? Or just see after this what you will get? So 2 into 2, this 2 get cancelled. So h t into h square by 4, right? Ht into h square by 4 plus t hq by 12. So what you will get here? T hq by 4 plus T hq by 3. Sorry, T hq by 12. So after taking LCM, what will we get? 12. Okay. So this will be 3 THQ plus THQ. So 4 THQ by 12. So what will we get? THQ by 3. So THQ by 3. So now we have Ixx. Similarly, I along this one, what will be there? B dq by TL. So this time 2 into T by 3 into H by 2 whole cube. So after multiplying that, what you will get? HQ T by 12. Okay. Now, so we have I, Y, Y. Now next is that I, X, Y we have to find. So let's find I, X, Y. So from this again, H T by 2 into H by 4 into H by 2. So from first, okay. Then H T by 2 into minus H by 4, okay, into minus H by 2. So after simplifying this, what you will get? HQ T by 8, or just here. So after multiplying, what you will get? HQ T by 16, right? 4 2 is 8, 8 2 is 16. So T HQ by 16 and plus here minus H by 2 into minus H by 4. First these two multiplying. So H square by 8 into HT by 16. So after multiplying that, again here T HQ by 16. Right. So after adding these two, what you will get? T HQ by 8. That is here. Or HQ T by 8. Right. So now we have section, we found the section properties that IXX, IYY and IXY. Okay. Now substitute these value in equation 1 because just see here that is required. Here. Right. Substitute now, not in this one. Here. In this equation because that is 0. So for finding this, substitute that IYY we found, IXY we found, IXX, IYY and I to IXY square. Okay. So just substituting that here, what we will get? Sigma Z equals to mx by htq, comma, right, into 6.86y minus 10.30x, right? Or just see here how. Okay, so now here we have to put sigma Z equals to, right? So first mx, okay, IYY is how much? HQ T by 12, IYY into y, okay, minus IXY is here, HQ T by 8, HQ T by 8 into x, okay, this divided by IXX is HQ T by 3 into IYY is HQ T by 12 into HQ T by 12 minus I square XY is HQ T by 8. So HQ T by 8 whole square. Right. This is there. So now just see here HQT we can take common. So MX into HQT common. Right. So what we will get here? Y by 12 minus, okay, X by 8 whole divided by, from here HQT square I am taking whole square common. So HQT whole square taking common, then what we will get here? 1 by 36, 12 3 is 36 minus 1 by 64. So this ST cancel. So now what we have? So from here mx, okay, into y by 12 minus x by 8 whole divided by HQT into 1 by 36 minus 1 by 64. Just simplify this one, right? So after simplifying, what you will get? Sigma Z just mx by HQT into 6.86y minus 10.3x. So this is the second equation. Now, so we have to put the value of x and y. That's all. So to get the value of, so on the top flange y is h by 2. Okay. So just put that here. So sigma z on the top flange mx. So for this y as h by 2. So after putting, what you will get? 3 point, or here just h by 2. So 2, this will get cancelled. So 3.43h minus 10.3x. Right. So this is for the what? At the top flange. What is the condition? Y equals to h by 2, where x should be greater or equals to 0 and less than should be equals to h by 2. Then only this y is equals to h by 2. And the distribution of direct stress is what? Here. Which is linear. Just see this is linear equation, right? So this is of the linear equation. Now, so now just here after sigma z1 for first part, whatever the value of x is there, just put the value of x and value of h that is given, right? So sigma z1 is minus 1.72 mx by hqt, that is compression. Sigma z2 is again after putting the value of what z2, right? Where is the what is the value of x and z? What you will get? That 3.43 mz by hqt, that is of tensile in nature, right? So now let's see. In the wave, minus h by 2 should be less than equals to y, right? No, sorry, y is should be greater than minus h by 2, greater equals to minus h by 2, or less than equals to plus h by 2, and x is 0. Again, the distribution is of linear form and is given by. So now just here, right? This is there. So now put what? Y as minus h by 2 to h by 2 and x as 0. So after putting here, what you will get? That m sigma z1, or simply that as h by 2, we will get what? Sigma z as mx into 6.86 y by hqt, from which what we will get? Now this is the sigma 2. So sigma z2 is how much? Plus 3.43 mx by hqt, and sigma z3 is minus 3.43 mz into hq by t. So this is plus, this is a tensile, this is coming negative, so it's what? Compression. Okay, so just see quickly once again, what is the question? The question is given as what? Determine the direct stress distribution in the thin wall plate section shown in figure produced by what? A positive bending moment, mx. So for bending moment, that this time we have to take mx. In terms of mx only, now we have to find the value, right, or the answer. So this distance is given h by 2, this is h, okay, and this is h by 2, and this is the shear center. Thickness is given as t. So means there is no numerical value, only in terms of h, t, mx we have to find, right? So according to this one, we know that sigma z is what? My, right? So this formula we know for sigma z, right? That is my into ixx minus mz into izy by izz into iyy minus I square xy into x, and similarly for y, mx into iyy minus my into ixy by ixx into iyy minus I square xy into y. Now here first expand, okay, and take mx term one side and my term one side. So after expanding and taking mx term one side, my term one side, it's just common my term, collect my term and mx term, and then take common mx and my. So after taking common mx from here and my from here, this is the equation. Now what is the condition? Where the direct distribution is required, vertical wave, where my is 0. So put my 0. Once you will put this my itself 0, the whole thing becomes 0, right? So now what is there? Sigma z will be equals to this only. Okay, so now sigma z is this one. Okay, so now here is the sigma z. Okay, so now what we have to do? We required here iyy, ixx and ixy, that is section property. So now let's find the section property. So for finding, this is the ixx, right? What we got? Ixx hqt by 3, iyy as hqt by 12, and ixy as hqt by 8. Substitute these value in equation 1, right? Ixx, iyy and ixy here. So now substituting in equation 1. So after substituting and simplifying, what we got? Sigma z equals to mx by htq, that is common, 6.86 y minus 10.3 x. Now here, based on the value of y and x, we will have the value of sigma z. So now just see, on the top flange y is h by 2, right? So and x should be, x is greater than equals to 0 and less than equals to h by 2, and the distribution of direct stress is given by, just put the value of h by 2, right? Y equals to, so here after putting y equals to h by 2, we got what? Mx by hqt into 3.43h minus 10.3x. Okay, so here by seeing this, what you can say, this is linear. So distribution will be linear only. Right. So now put the value of h and x in from the given figure. Then for sigma z1 it will be equals to minus 1.72 mx by hqt. So this is minus, means it's a compressive in nature. Right. Next, sigma z2, again after substituting the value of at 2, what you will get, plus 3.43 mx by hqt. So this is plus, means it's a tensile in nature. Right. So now just see. So now we found sigma z1, sigma z2. Okay, so now just see again. So in the wave, this is what, on the top flange. So this value is for the top flange. Now what we are finding? We are finding for the wave, right? So in the wave, y should be greater than equals to minus h by 2 and should be less than equals to h by 2 and x equals to 0. So just put x equals to 0 and y as that h by 2. That should be. Again the distribution is of linear from, and it's given by the equation what? Just substitute the value y as h by 2 and so sigma z will be equals to what? mx by hqt into 686y. So now this we have the value of sigma. Now next is what? Again we have to find for where, from wave is, just see the figure, wave is from 2 to 3. This is what we have to find, sigma z2, sigma z3, right? And just see here, sigma 1, 2 will be equals to sigma 1, 4. So whatever the sigma 1 will be there, that will be equals to, that sigma z1 will be equals to sigma z3 and sigma z2 will be equals to sigma z4 in this case, right? From here. So just for 1 to 2 to 3 we have to find. So here, okay. So sigma z2 will be equals to what? Again just substituting here 3 point, because that is h by 2, right? So mx into 3.43, okay, and z into by hqt, okay, and sigma z3 will be equals to minus 3.43 mx by hqt. That is again minus, so it's a compressive. So sigma z2 at the what wave will be tensile and sigma 23 will be compression. Okay, so for the reference you can just refer the THG Maction book. Okay, so if you have any doubt regarding this question, you can just comment on the video or you can just contact me so that I can clarify your doubts. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.